The role of SEMIs is to develop and enhance participants' skills. Thus, topics to be covered include seed classification systems and their production requirements, and how to produce seeds from crops with different breeding systems, for instance, maize versus wheat, and other crops including vegetative propagation. Seed production, planning, and course planning were also covered. Each training has to practically do this and come up with a clear plan for the seed production for their company. Agronomic management of seed crops will also be included. Crop protection challenges, which can interfere with production of quality seeds, will be extensively covered. In addition, the participants will go out in the field and do actual crossing and appreciate the basics of distance specifications, as far as, for instance, maize, sorghum, millets, wheat, sunflower, beans, green grams, cowpeas, dolichos lablab, pigeon pea, to name just a few. In addition, a field tour has been planned to Kalronjoro, where the focus will be on winter cereals and sweet potatoes. And I have the president there is one, their company they converted and they moved, and I visited them. They have actually established facilities for that. Some heritage, where is heritage? Haruna, you are doing both. You have certified as well as the other. The only thing I understood from their system is what if you're going to do both, you still have to have a different business entity, either subsidiary of one, but you have to have a separate. So there are some changes starting to make. I think I identified you are about 4 or 5 of you who are doing that. So I think we can engage directly so that I'm still inviting you to come to the field, in other words, if you want more engagement. Okay. So that you allow what she has gone through, Dr. Zube, preparing, and we cancel. I think we have cancelled this training, has been postponed 3 times. Lucky enough, she was, it's good sometimes to go to school. She had planted in relay that if this one fails, there's another. So she'll feel very disappointed when the people who are to come and do are here. So I want to appreciate you. Thank you. Donald, I think we have interacted. Yes. Now when I sit here is when I say you are not a stranger in the house. We have interacted, and we hope to work together and see how we move this forward. Dr. Giro, thank you for coming. We'll be talking to you. We are still here. Yeah.
Because the bee fly was actually controlled, we did the top dressing, and then one other operation that was done, and which has been mentioned extensively in the training, was the removal of off-types. This kind of variety is determinator. So one thing is to exclude and to remove everything that does not look like that particular variety. And in your training, you'll be told that the one of the important things to do when you're producing seed is you have to keep monitoring, you have to do roguing, and you remove out any off type, something which is bound to interfere with your seed production and give you off types. It will give you the wrong variety. If you just call this seed, it means that if you have off types and something which is not from the same variety, you're going to have the wrong type of seed. You're going to give the farmers the wrong seed, and the farmers are not going to get the yield that they are actually expected. And then the other thing is, we have somebody who is supposed to demonstrate on how to actually do a crossing for beans, who is involved in pulses. Anyone in legume breeding, legume seed production? You have, So we have someone who is just demonstrating on how can you go about crossing, because this is field. How do you cross the bean crops? So that we don't, when we move from here, we just go to the next crop and finish up. We don't need to come back and demonstrate the crossing and so forth.
Good afternoon. Good afternoon. Yes, now to cross beans, you basically need to have 2 plants. you have the female plant and the male plant. The female plant must have more of the positive attributes that you are looking for than the male plant, because it is not easy to transfer so many traits from one plant to the next, but it's easier to transfer a few traits. Now, for you to be able to transfer successfully, you need mature pollen. So you need to plant your male plants first. After a week or two, you plant the ones you intend to use as your female plants. The ones that will receive the pollen, we'll call them the female plants, and the ones that will be the source of the pollen are the male plants. Then, since bees are about 95% self-pollinating, you will need to try as much as you can to get rid of the male parts of the bean flower as early as possible before they self-pollinate. And this is possible a flower like this, which is just about to open, has mature female parts. The stigma is receptive. It can receive pollen and develop to a pod. But an open one, like this one, it has already pollinated itself. So even if you want to pollinate this one, you will not get anything other than a self-pollinated product, which will be your F1. So after that, you get a mature female, which is also a mature male, which has just opened. Now the ones which are open, like this one, these will be now the right donors of the pollen grains. So you transfer the pollen grains from this one to the one which is just about to open. So the bean plant has 9 to 10, up to 12 anthers. You have to remove the anthers in a process we call emasculation. After removing the anthers, you now bring the anthers from a mature opened flower and transfer them to. So you wrap them on the stigma, or you can just hang them so long as they are inside, and you cover the place gently. It has to be done when the weather is cool, either very early in the morning or late in the evening, because pollen is susceptible to high temperatures. So at least between 15 to 20 degrees is okay. 25 and above, you are not likely to have a success. Most of the flowers will report. Now you come closer. So let me just open this in a rough way.
See how the brackets are being opened.
Are you seeing those tiny?
Stigma.
Those ones.
Anthers.
These are the stigmas that carry the anthers.
Yeah.
And you have to do it very gently.
You remove them.
Are you seeing those? I want to show you. Are you seeing those ones? Are you seeing that? Now, the white part. Are you seeing that white part coming out?
Yes.
That's now the female part on which we shall hang the pollen from the male part. Are we okay?
Yeah.
And it has to be very gentle, because if you do it in a rough way, you just break everything.
Okay.
Then, because it is done pod per pod, you label that. Now on this label you have to write the description of what you have used. Now it will be the male first, then the female. So if plant A was the male, you write A by, that's, you do the multiplication sign, then B, the female. And you use a pencil, because a pencil can stay longer. And when weather changes come, like rain and everything will be washed out if you use a ball pen. But a pencil can stay longer. Then you come to, assuming our flowers are intact on the plant, you come to the plant. Are you seeing? It's just directly on that pot that you crossed. You tie tightly, but not breaking you ensure you don't squeeze the stalk that attaches the pot to the main stem. So after this, you will be required to continue checking for the survival. If you do 20, your survival rate, you might get 6. So it is a delicate exercise for you to get that successful crossing. Do you have a question up to there?
Yeah, I have a question.
Yes.
Okay, like if I just did to one flower, does it circulate in all the plant?
No, a single cross gives you a single pod that will be having as many seeds as that pod can carry. If the pod is going to carry 5 seeds, you will only get 5 seeds which are fertilized by the new pollen you brought, not the entire plant.
Okay.
Yeah. The requirement of the flower to use as a female is a flower that is at that stage.
Like it was meaning like.
But it doesn't matter where it is, so long as it is within that plant that you want.
Okay.
Then the male is also one that has opened. So the pollen, the rate of maturing of the male parts of the flower is slower. That's why you have to plant it earlier.
Excuse me.
Yes.
I would wish to know whether, since you are just using you are crossing on the flower, is it possible for you to use different males for the same
plant,
but on different flowers?
So long as you label, it's okay. But if you don't label, when you harvest, you will just be having as a mixture of everything that you cannot define. Yeah. That's okay?
Yeah.
So we can move the next.
The next we can have.
You want to move out of here?
Yeah, before we move. If you have
Before you move out of here, we talked about insects, and you saw some in there. So some of the insects, there are white flies on this, as you can see. Remember those of you who came to the lab? Yeah. We had the white flies, but they were on an ornamental crop. But the beans also get white flies, and most times they settle at the underside of the leaf. So when you are doing your monitoring, if you don't look on the underside, you'll see very nice beans, and yet the nymphs are settling there and they are sucking the sap. And they don't only suck sap, they also transmit diseases. And I think when you'll be looking at the diseases Nyang'anga has put there, some of them have been passed on by this white fly. So they controlled the bean stem maggot, but they did not do anything about the white flies, as you can see.
The bean seeds, which we have just displayed here, are the results of the breeding work and now already at commercial level. And this is what is expected of the seed companies at the end of the day, to be able to produce quality seeds at affordable price so that the farmers can access this good seed for improved food and nutrition security in sub-Saharan Africa.
This maize variety is AC Duma, which is bred by Sidco. It was planted on 10th of April this year. So it is majorly suited for mid and high altitude areas. As you can see from here at planting, the normal agronomic practices were followed. These are spacing of 90 by 30 centimeters, recommended spacing. It was at planting, it was DAP. We used DAP, and thereafter we top dressed. We have not top dressed, just at the moment, at the point of top dressing. So one of the things we wanted you people to appreciate is some of the nutritional deficiencies. If you observe the plants, especially the tillers, if you look at this, you are able to see there's purplish coloration, right? Yeah. Even at the end, that shows the plant is lacking nitrogen, right? So it really tells you that at this point you should have top dressed with the CAN. And then for breeding purposes, it is recommended that you leave in each. There should be only one tiller, one plant per hole. So when you are coming to do your crossing like this, you should be able to remove these excess tillers and only leave one plant standing. So for this normal standards, for you to ensure that your work is efficient. So apart from those, there are insects, pests, which Professor will want to talk about, especially on these. So you can come close at least.
They did do stalk borer control, but we still have evidence of the larvae having been there. But I think when they controlled, it did not continue. So you did not get dead hearts, but you got the leaf damage. So this maize can still survive because it's only the small leaf damage that managed. And we have another one here which has the same pattern. And you remember when we were talking on pest and pest control, the difference between the fall armyworm that is now devastating maize in Africa is that they don't do this. They eat in a manner that is not in a pattern. So it's very easy to tell the damage from the one of the stalk borer, between the stalk borer and the fall armyworm.
Okay. You remember the isolation distance for maize? Yes. Stem applies 400 meters for basic and then 200 meters for certified seed. But this is for demonstration purposes. Okay. So we head to.
I have a question.
Yes.
Yeah. Concerning like the pest, like this stalk borer. Like in my country, I can see even if it start like this, then at the end even it will consume the whole fresh leaves. Then at times even the plant cannot grow again.
Yes, they start like this because you remember I said it starts eating from the heart. So this was eaten when it was still small inside there. But I think they managed to put the control in time, and that is why these other ones are not coming out with the same. So the larvae that was there that managed this damage actually died. But if it didn't die, then it was going to continue eating, and you would either get the dead hearts, or if it survived on, then it goes down into the stem, and you saw the open stem that we had. So that is what happened. You can stop the progression if you manage to put the control in good time. But the best thing is actually to prevent so that you don't even get this.
What time of do you till? Like, okay, removing the other one, because like if you leave up to this time, I think it will disturb the roots of the other one if you remove it right now.
Yeah, actually, for hybrids, normal maize cannot tiller. Yeah, but for hybrids, because they are very. I told you they have what we call what? What do they have? Hybrid vigor, and that's why they tiller a lot. This is not a normal maize. These are basically tillers. And they need to be removed very early. As they grow, they need to be removed. But during planting, most time you plant 2 seeds per hill. This is a hill. You plant 2 seeds per hill. So you have to thin that hill to just one seedling. You have to leave only one plant per that hill. Yeah, so that you reduce competition. But this is a tiller. And the reason for the tillering is because the plant is showing heterosis or hybrid figure. And you have to take, because this one at the end of the day, you not get anything from there. Or you are going to get very funny cobs. Yeah? Yeah.
Now we cross maize. Sindio? The difference between maize and beans, like we said, common beans, but because there are some other beans which are cross-pollinated. Common beans are self-pollinating at about 95%. But for maize, it's a cross-pollinated plant, and so the approach would be different. The male plant and the female plant equally have to be planted at different times. The male plant has to be planted earlier because the male part of the plant is the tassels. It is in this that we have the pollen grains to use. And it is the ears that give us the female parts that we are going to pollinate. Now the female parts, just when you have planted your crop, you wait till when it just starts showing the silks. This is what we call the silks. Then you cover these silks with a transparent polythene sleeve that is open at one side, like so. You hold this for me. The reason of covering is to prevent pollination. So, after you've covered, you ensure you don't close the lower part because you have to leave this place well aerated. Then, when you come to getting the male part of it, you get a manila bag, like this one. Maybe like this one. So if you put when you put this inside and you shake, on shaking, inside here we shall have the pollen, which we shall transfer to this female part that is receptive. So we cover like so. So this, the seeds we shall obtain here are the seeds that have a mixture of traits. That is the trait of the male and the trait of the female. But the assumption we have, our expectation is that much of the male traits that we are looking for will be expressed in the maize kernels that we shall harvest. But since maize has a lot of kernels, and its traits are quantitative control, it has many traits many genes controlling one trait. So you will have to go through selection. You plant this and you check for the trait you want. When you select your female, you also ensure that the female you have got, you remove the tassels so that it's only pollinated. You reduce the chances of having any other source of pollen accessing your ears. The female part is also called the ear. Am I clear? Yeah. Do we have something to be clarified?
One, I'm talking on maintenance.
Yes.
When you are maintaining
yes.
the variety, isn't it?
Yes.
You may cover this one and this one.
Yes.
So how can you know that this is the right time to
cover?
To get a pollen from here and
when you get to the field, just after the plants have developed the tassels, after a week or so, if you shake it, you will see some pollen coming out. That is the right time to collect the pollen. But immediately the silks appear, cover them. Because if you give them some extra time, they will easily be pollinated by other sources of pollen, which may not necessarily be from your field. It can be even from a different far distance. Because I'm told pollen can travel some reasonable kilometers. Pollen can come from even 100 kilometers away and pollinate a plant here. So for us to be safe, you cover immediately you find the silks coming. But you ensure that the bottom part of the sleeve is open. And you collect using a manila paper, because this manila paper is able to provide some aeration that is very important. Like I told you, the male parts of this of the plant systems are so weak. So the pollen is so weak. If you subject it to some stress, of course you will transfer pollen, but it will not be effective. And it's so advised that it is done in the morning or in the evening. Am I clear there?
Yeah. Pollen to female part.
Yes.
You find that when harvesting,
yes,
the cob, the grain are scattered on that cob.
Yes.
What happens to
the
that?
grain is not, the cob is not having a uniform distribution of grain.
Yes.
What happens, all cobs have the female part of that grain intact. It only swells up to become a kernel when it has been fertilized. Are we clear there? So, if it was not fertilized, it will not grow to become a grain or that seed that you are looking for. So, if what will make it not, what will make your crop not to have that even distribution of seeds, is because it was not fully, not all the kernels that were there were fully fertilized. So lack of fertilization, that is even that brings up that.
But I also have an issue, yeah? We have the challenge of the MLM. In this field, we try to control the MLM, and as you can see from him here, this one. It's actually here. We still have MLM affecting the crop. But one thing that has been discovered with the issue of MLM, especially in East Africa, we have grains forming, very scarce grain forming, and then the rest of the crop is empty. And partly it has been associated with the maize beetle necrosis disease. Okay?
Maybe you never get you handle it roughly, where it never survive. What will be the impact on the cob of the female?
Of course, if you don't put pollen, you get no grain. Yeah, you get no grain. If you don't put enough pollen, you also get a poor cob with not enough grain. But anyway, before you even cross, you have to, because you pollinate when it's a bit young. Yeah. So one thing, most of them may not have really exposed the silks. So what you do is you open up and cut. Yeah, like you cut. In case you don't see the silk, you have to open up and cut and keep it ready for crossing. When you get the pollen, you come and just pour it and cover your cob.
Maybe just to add on that about the contamination, when you're transferring your pollen from the tassel, do not put your fingers or inside on the pollen, because that will lead into contamination. And then the other thing that maybe was not mentioned is that labeling is so important. You have to label your lines. You label your line, and if you are doing a single cross, if you are doing just a self-pollinated, you just correct, and you are taking pollen from the same plant and then to the same. You have to label that clearly. And then you are transferring, maybe you want to cross from another line to this other line. Usually you label with the female first, and then the male later.
A question. According to DUS, how do you judge this field in terms of this thing, and then uniformity, then stability? According to what I learned, it's like there's difference in the color of the silks. So I don't know. How do you judge this field?
But this is an OPV, yeah? This is not really like anything so unique. Huh? This is an OPV, so it's bound to go through outcrossing. Yeah? Yeah. But for a real variety, for a real hybrid, you need to see some, like if you go into the farmers' fields that are really working on maize, you see the things are uniform, the tassels are like similar, you see a lot of uniformity. But for this one, which is really an OPV, you don't expect much of it to be like uniform. Yeah. There are so many gene combinations. You understand the breeding? Yeah, there's a lot of gene combinations all over. Tall ones.
They can also come in.
Yeah.
Because I once said that it's 24 hours.
Yeah. Not more than that.
Not more than 24
Yeah, within 24 hours. Actually, the more you get to 24 hours, the closer you get to 24 hours, the less effective it becomes.
Okay,
Yeah.
so my question is, when you transfer the pollen from the tassel to the ear,
Yes.
how sure are you of what population of the ear you have actually covered? At what stage are you supposed to, how do you identify when to cover the ear? You get my point?
Yeah, I think we need to
Maybe
move
we
to,
go- we
like
move
now
to
this
the-
one, assuming we want to pollinate. This one is a good one. You know this one, because you cannot see the silks,
Yeah.
and at least younger than this. And what you do is, I don't know whether there's one which is really hidden, yeah. But there are some which are actually like hidden. So you don't wait for it to ever have a here and here. This one, the silks shooting out. But at this stage, what you do is you open up. Just hold for me this one. You just open up this one. You know, if we had something to cut, you just open up. And then you're going to expose some silks. Yeah? You cut, you open, you expose some silks. And then you put the silk bags. The polythene these ones, the silk bags, you just put them, assuming we have cut and we have got access to the silk, yeah, then you just put it there. Yes, and then what you do, you put a tag. Yeah, you make sure that this plant is already tagged, because you don't want to come and do pollination in the wrong plant. And then if you are doing cross pollination, you go ahead and identify where do you have pollen, where do you want your male to come from. Then you put your this is a pollination bag. You put your bag on the tassel, and then you collect enough pollen. And then when you come, already what you do, as you collect the pollen, you already label your bag. This pollen is meant for this particular mother plant. So you label your pollination bag. When you come and pollinate, this pollination bag already has a label on it with the mother plant. You come and you pour your pollen, yeah, and then you pour your pollen, and then you cover it, and then you have to put, already you have the male parent, the female parent times the male parent, and then you staple it, and then you wait for it to mature. Okay, so in harvest, if you are dealing with single cobs, you come harvest your cob together with the pollination bag, and then you dry your cob, you get your seed ready for drying and so forth. If you're planting, then at least you are sure this particular hybrid is from male eggs and female eggs. Okay.
Okay. My main question was on the part where the silk is coming out from the top. We say that the first silk is from the bottom, yes? So if it takes 5 days for the silk from the bottom to that on the top to come out, at which day are you supposed to transfer the pollen? Because it's only going to take less than 24 hours. That was where my question was.
No, it's not necessary that you are going to collect pollen from here unless you are doing self-pollination.
Yes, that I understand. But now on the female part.
On the female part, that paper is very transparent. So you'll be seeing as the silks come up. Yeah? And then once you are able to view the silk, then you are able to go and collect your pollen and come and put it here. Because you cannot pollinate if you can't actually see the silk. But once this thing comes up, you have to put a silk bag. You cannot wait for these things to emerge and then you come covering. You'll be wasting your time. Okay?
This variety of sunflower is called Record. We sourced it from Caro, the breeders itself. So the spacing is 75 centimeter by 25 centimeter. That is what we use. That planting, we did the DAP. We planted the DAP, fertilizers. And then after 1 month, we did the top dressing with the CAN. Again, the agronomic practices on sunflower. Sunflower is rather easy to manage on the insects and pests. We used imidacloprid, that was Defender, to control most of the aphids which were started to appear. That was done just 1 month after planting. So if you can look at the stand, generally the stand is not uniform because we had to do some gapping in that the germination was not 100% for this particular variety. So we did some refilling. That's also called gapping. So it tells you that even some of this is the germination before you plant, although they write sometimes you may not achieve that 100% germination capacity. So as for this, usually the fluorescence, this is usually a composite. The fluorescence for this is in that you get several inflorescences in it. There are many flowers. If you look at one that is already open, maybe perhaps this one. So this is a composite in that you got several inflorescences, several flowers, anthers and stigmas in here. So you'll have several seeds that are coming up. So for breeding purposes, normally they do it in a bag. In that you do this all together, so you don't select a single inflorescence when doing the breeding work. So much of that on how the crossing is done, when we'll go to Karo and Joro, they'll be able to tell you that specifically, especially this and even for for the pearl millet, how they do it, because it's a composite, and usually it's very difficult to deal with each flower single.
Yeah.
The major pest for this usually is just the birds. The birds, they can destroy a whole stand population for the sunflower. But otherwise, it is very easy to manage, and harvest, you are able to get something.
So we go to
Okay, so we go to pearl millet to appreciate, because we have the diseases to look at. It's green gram again. It is not usually adapted to very high altitude areas.
Like soya.
So that is why it has not flowered.
It looks like soya.
Yeah, it resembles like soya, but soya is on the other side.
What kind of is it? Yeah. Yeah, I think here.
And the rooting system.
No, it's damaged. It's very damaged there.
Yeah, on the leaves here, you see the leaves are kind of wilting. So it might be a fusarium wilt or a bacterial wilt. Might be fusarium wilt, but if it's not hollow, it might be a fusarium wilt. So you have to go and do some isolation in the lab to determine the causal agent of the wilt.
Okay.
Yeah.
What if we don't have a lab?
Put a clean water in there, get a blade, just cut, and not have a blade here, just cut a wedge.
There is here, I think it's one of those seed the dumpling off.
Oh yeah.
Is there the black?
Dumping also.
Yeah. This is also dumping off. You see the blackening in this thing. Is a black root lot. Yeah. The black root lot. So causal agent, mostly the dumping off might be caused by the Rhizoctonia or Pythium. Yeah. Or Sclerotinia. Yeah.
So this is where we're talking, we call this condition dead heart. So the heart of the plant dies, and then once it does that, from the base of the plant, you get what we call tillers. So there will be some new shoots coming from the base. So when you have this damage by the shoot fly, then you get the tillers to compensate the plant. So you'll get more than one plant from, like now you can look at this one, at the base here. So you have so many. This one is dying, this one is dying, the others are fresh. So you keep having new shoots.
We have barley here.
Okay.
And then we should be able to distinguish between barley and wheat. Yeah?
But there is contamination.
Yes.
Of wheat.
That's why it's very important to do your removal of off types. This one is not. This is wheat, but then we have barley, and there is a very clear distinction between barley here and then wheat is on the other plot. But wheat is not usually adapted in a place like this with very low temperatures, yeah? As opposed to the barley. Much of the crossing will be seen when you go to the field on Friday, yeah? Because of time.
They look alike almost.
Yeah,
They look alike, but they are different.
They look alike, but the clear one is this.
The
Barley is 2 raw ons. Wheat is confused everything. So pick the wheat.
It's very organized.
Put it out.
There's wheat
But
there.
this one is very organized. You know,
Yeah.
it's 2 raw ons. That side and that. But this one is right round. The ons are right around. And I can see the Septorium nodorum here. Where are you? The Septorium nodorum here. Yesterday I was showing you in there. So that's the two you differentiate very easily. 2 raw and the other. Because sometimes morphologically, the leaves you can be struggling unless it's a crop you are working with all the time.
Yes.
Yes. So can we be moving?
Yes, you move out now.
With banana, Sigatoka, the disease, and the causal agent, Mycosporella musicola. So as you can see, we have 2 types. We can have the black Sigatoka and the yellow one. The tissues around here, for the black, they will be black. The tissue around here. For the yellow one, the tissues around will be yellow. Okay. So, okay. This is a mosaic. This is the crop is a sunflower. As you can see, mosaic. This is mosaic. Those are shades of dark green, light green, and yellow. Yeah, time is not on our side, so that's why.
It's not level, huh?
This one is sunflower. These are leaf spots. Leaf spots, causal agent, alternaria. Cause the alternaria leaf spots. Leaf spots. Leaf spots. These are leaf spots. These are leaf spots. The crop is cowpea, caused by Septoria pigenicola. We are moving fast, and this thing is coming out. Beans. These are this is rust. These are bean rust. If you have a look at the back side of the leaf, you'll be able to see some brownish pustules in the underside of the leaf. Yeah, the labels are there. So this is also beans. The disease is a common bacterial blight of beans. As you can see, there is this blightening here on the surface of the leaves. Yeah. And this is angular leaf spots. Angular leaf spots. You can see the necrotic part is being restricted into the veins. It's not going beyond the veins. So it appears like angular kind of. This is Coledotrichum. Coledotrichum on beans, but this time around on leaves. Sometimes it appears in the stems and also in the pods. They are sunken, then giving some kind of tingish. We have also mosaic in beans. Mosaic, as we have talked, those shades of black, of dark green, light green, and yellow. And sometimes, if you can't see the distinctive areas, then it becomes a mottle. This is also a mosaic, golden yellow mosaic. You see, it's yellowish, golden yellow mosaic. Yeah, this is pigeon pea mosaic. Pigeon pea leaf spots caused by Mycosphaera. The causal agent is there. This is cassava. That was golden yellow mosaic virus. This was cassava. The symptoms here were not very clear. These are leaf spots, Sarcospora leaf spots. Yeah, Sarcospora leaf spots. This is also mosaic on cassava. Yeah, mosaic. So sorghum rust. We said rust. The back side of the leaf, you will see some brownish pustules. Another leaf blight.
But you must also on that. We must be having Coledotrichum on that.
On this one.
Sorghum.
Yeah.
They tend to be together.
Okay. Yes. So we have this is a northern leaf blight. You see there is this blightening here, and then it's kind of runs along the veins, and it's not sometimes restricted along the veins. It can spread. The same is the same, but this is on maize, this is on sorghum. The symptoms are similar. Sugarcane mosaic virus. Sugarcane mosaic virus is related to the MLN. The two viruses, one of them is. The other one I think is dwarf mosaic, maize dwarf. This is gray, but it might be contaminated with Coledotrichum. Gray leaf spot, some parallel. The blight runs parallel to the leaves, but mostly this might be Coledotrichum. But as we said, you have to isolate for you to be sure. This is also the same. This is a gray leaf spot. This is gray.
We have already seen it.
Oh, you've seen it, yeah.
We had a typical symptom here. This is the typical rectangle.
The barley, there is the blight here, the fusarium. Yeah, the head scab.